Hello, welcome to EDW Automation Best Practices at the Data Platform Virtual Summit 2021. Over the next 45 minutes, I'm going to be showing you a demo of the design and automation best practices that we use to build enterprise kind of data warehouses, focusing on Synapse SQL dedicated pools. For those of you who don't know me, my name is Bob Duffy. I'm a SQL Server MVP. I'm also a certified architect, or used to be called a SQL Ranger, an MCM, and a few other things. I suppose the most kind of relevant thing is that I work as a data architect, and I help a few teams in my company build enterprise data warehouses with a modern focus on the Azure data platform, especially on the Synapse framework. So this talk really comes from our experiences, and what we've been focused on is the design principles of agility and extensibility. So if you do kind of meet me, I love to chat about any of this. I'll quite happily engage in email conversations, ideas and stuff like that. Just reach out to me, email, Twitter, or anything else. Okay. Now, what we're going to be talking about in a little bit more detail is, first of all, I'm going to show you just some sample source code that has a basic metadata-based automation framework, and I'm just going to start from scratch, like no ADF packages, no SQL pool, no kind of source data. I'm going to set that from scratch, and then I'm going to show you the principles of automating extract, which is probably the easiest part, right? And then some of the more enterprise features that add on to that, login, lineage, error handling, perhaps, and then move on to more complex aspects of automation, transform and loading, especially into star schemas. And the final thing that we're going to look at is how to achieve dynamic orchestration so we don't have fixed workflow. Okay, so this is a demo-based thing, so that's the last of my decks, and I'm going to jump straight into getting it set up. If we flip over to the internet, there's a starting point is I have put a public Git-based Azure DevOps repository called AdventureWorks. There's a URL here. No need to write that down because it'll be available in the download, and I'll see if I can paste it in the chat as well. And what this has is some sample source code, sample stored procedures to deploy a basic metadata framework for automating EDW load. There's a bunch of prerequisites because obviously to do it in Azure, you're obviously going to need your Azure credit, a DevOps team site to put the source code into, SQL Management Studio to connect to the environment, Git for Windows, and a few other recommended tools as well. Then once you've done that, you can clone the source code to get your own local copy of the source code. Now I'm not going to do that as part of the demo because cloning a Git repos is quite a basic thing. So I've already done that. So I've cloned it, and on my computer I've now got this Git repos, and there's some labs in there. And one of them is to automate the installation of Synapse. I've got a Word doc, and I'm just going to run some PowerShell scripts to create three things. A data lake, so we assume that all of your source files are going to be in a data lake, all right? Now you could not have them in a CSV or Parquet format. They could be copied direct from a SQLDB or an on-premise by the IR, but a lot of projects you'll have CSV files as your startup, perhaps, or Excel files or something like that, right? Then we're going to automate the creation of a Synapse environment, so an integrated Synapse environment, which is where we can deploy our ADF or our ETL packages to, and three, a SQL pool, so a scale-out environment. Okay, so I'm going to double-click on the data lake, and I'm going to run the first script. So I'm going to open that up in Visual Studio Code or whatever editor you have. I'm going to type in a bunch of parameters, such as my tenant, my subscription, what resource group I want to create, and so forth. And then I can log in to Azure. So I'm just going to log in. I'll log in under that account. Once I've logged in, I can automate the creation of a resource group, creation of a storage account, and if it's got the right properties like storage account v2, it's basically a data lake. I'm going to create some landing zones, which in this context are basically containers within the storage group. And then I'm just going to run that. And then the last thing is I'm going to copy from the public source code into my new data lake some sample files. So I've got some reference files and some raw files that I'm going to copy in, and that's going to be my source that I want to automate the extract from. So let's run this. So I'm just going to select that first bit again. Now I've already logged in. Run. Now, take a while to run. That's created now. And then I'm going to run the last part of the script to just copy in the sample files. So let's run that now. Push F8 to just run that bit of code. And now, there you go. So that's copied 22 files. And just to check it's complete, I can run Storage Explorer to look at the data lake. I'm going to refresh my labs, and I should have one called, here we go, Bob AdventureWorks Data Lake. I've got my zones for there, and in my reference zone, I've got a folder in ERP CSV. So I'm going to assume that this has been extracted from an ERP. I've got these various files, and then in the raw, I've got some files coming from, is this trans? No, not this one. Sorry, coming from the finance system, finance, ERP, transactions, CSV. I've got a sample transaction file. Okay, so that's my input file, all sorted. I've created a data lake, and I've got some sample files on there. Okay. Now, the next thing I'm going to look at automating is the creation of the Synapse environment. So this sample script here, install Synapse, will fully automate the creation of an integrated Synapse environment. So I've got my parameters at the top, a little bit of a naughty. I've got a password stored in plain text, so you should probably have that encrypted. I'm not worried about that so much because I'll have deleted this environment long before anyone gets a look at it. I can then create my Synapse workspace, a little bit of security work to create a managed service account and grant that right so that the SQL pool will eventually have permissions to connect to the data lake and vice versa. And also a little bit of firewall work. So I'm going to use a web service to grab my current IP and grant it access to the Synapse environment. Now you can pretty much do all this manually as well via the portal, and a lot of projects where we just create it once off we would. But I'm going to automate the creation of the Synapse environment now. Now this bit does take about 5 minutes, so for the sake of the recording I'm going to cut out that bit, right? So let's give this a go, and we go. Right, so it's started to create. It's going to log in. It's going to ask me to authenticate at this point. Bang. Now it's going to hit this block. It's going to take about 5 minutes, so let's just wait for that. Okay, so now that's finished. It's also run the code to add my client IP, so I can hopefully connect to the environment via Management Studio. Let's just go into the Azure portal, and when I go into Synapse Analytics, I can see here's the new Synapse server, which has just been created automatically, right? And if I go into firewalls or into networking, I should see that it's added my IP address for me, so I can access all the environments. And it's also given this Synapse environment access to the data lake that we created earlier, right? So that's good. So that's now created that automatically. And the last thing I could do is install a SQL pool. Now again, this can take a few minutes. I give it the base variables, just the name of the subscription, the workspace, and everything else. And once I've done that, just in a one-line command, new AZ Synapse SQL pool, I can create a new SQL pool and give it a performance level. So I'm going to start off at a 200C, but a 100C would probably be more than enough for the sort of stuff that we're doing. And then I can look at granting permissions and stuff like that. So here, this is the code. Now, I haven't fully automated this, so this just generates SQL statements that I can then run in Management Studio to grant the relevant permissions. I'm also creating a SQL account, like that's not a two-factor authentication, because some older tools like Visual Studio, Schema Compare and stuff like that, they kind of need a SQL account because they don't work yet with security principles and stuff like that, right? So let's just run this now, and hopefully what we should get is a SQL pool created that we can use to import our staging tables, automate or extract, and then look at our transform and load. Excellent. So now that that's created the SQL pool, this last thing I'm just going to do is to add some accounts. So first of all, to grant the MSI that the ADF might use so it can connect to the SQL pool, and then I'm going to add a SQL account just in case we have any DevOps. So we want to run like a schema compare from Visual Studio. So I'll go to Management Studio. I'm going to connect, and I'm going to connect to the server name. I'm going to use my Active Directory authentication. Bang, I'm connected, and I now can see that I've got an empty, completely empty enterprise kind of data warehouse. No tables, views, or anything like that. I'm just going to create a new query to just add those security accounts. Okay, so I'm going to run this in the AdventureWorks to create the managed service identity so that the Synapse environment can connect to the SQL pool. I'm just going to run this in master just to allow the to create a login so that there's a SQL login for the master, and I'm going to create a user in the AdventureWorks data warehouse, just a SQL user. I'm going to create a starter schema as well called staging or STG. So if I go to storage, there's security schemas, I've now just created one schema. I'm going to put all my staging kind of tables here. So most people try and arrange their staging area into zones, either one per major source, or they might just create an area within the SQL pool just called staging. If it's a smaller system, it might just have a single staging area. So I've now got an empty SQL pool, and I'm ready to go. I have a completely blank environment now. So now that we've got that empty environment within our SQL pool, just to show that again, if I go back to Management Studio, you see I've got no tables or anything. What I'm going to do is I'm going to deploy a starter schema that's got some stored procedures to have a metadata-based extract. So within the source code that we used, that we deployed, there is a data warehouse project called AdventureWorks DW. So I can open up that, and then I can right click and go, and in the properties I can publish that, tell it where I want to publish it to. So I'm going to publish it to the empty Synapse that I've just created, tell it what the name of the master is, and I can either generate the script or just go kind of publish. And what's going to happen now is it's going to create, well, depending on what's in there, it's going to figure out how to create all of the objects. And what we've basically got is a bunch of tables to store kind of metadata to help describe the extract process. So soft coding of it, so developers don't write code, they only register stuff in kind of metadata, and then some stored procedures to convert that into the appropriate instructions. So for example, if I go into DBO, reader extract is going to extract a particular object, and then I've got a controller to run what we call a controller worker design pattern. So the controller will queue the work, will pass it on to workers to actually extract it. That controller worker design pattern, if you want to Google that, is a very standard design pattern used for kind of multi-threaded automation. Right, now let's just leave this running. It's running away here now. Once it's finished generating the DAC pack, it will then apply that kind of DAC pack to create all the objects. Here we go, that's just there, creating database scripts, executed, that's now created all the objects hopefully. So when we come back to our Management Studio, right click and go refresh, we've now got some starter. This config schema is standard, so every EDW will have the exact same config and audit schema. It's just the DBO schemas and the staging schemas that will be different depending on the project and the customer and so forth. Within the procedure, we've got some standard procedures that do the framework, so login, lineage, automation, right? So now I'm ready to start. I don't have any data in any tables at all, so I've got to populate the kind of metadata and then start to write the extracts and then the transforms and the loads. So let's have a crack at that now. Right, within our source code that we've downloaded, there's a folder called labs, and there's some SQL notebooks that I'm going to start the extract automation. So I'm going to open an Azure Data Studio and point it at that extract automation to open up the sort of Jupyter notebooks or the SQL notebooks. So here it is here. And what we're going to do is look at building a metadata-based system extract controller. So we have a bunch of tables here, and these config tables are what I'm going to use to store the metadata. For this particular extract controller, I've got 4 metadata tables. Configurations stores the endpoints for my configurations. So I'll have a different endpoint per environment. This could be the name of the data lake, or if it was connecting to another SQL server, it could be a connection string if it was SQL to SQL, or it could be anything like that. But generally, it's going to be the name of the data lake, right? And that's what we can use to make the poly-based commands or the copy into commands to extract files. Data sources, there'll be one per unique data source. So think of this like a zone in a data lake. It could be an ERP system, it could be a folder, it could be, you know, the granularity is up to yourself, but that defines certain shared properties of the files. They're generally all going to be in the same type, like the delimiter is going to be the same, and there's various flags that we can set to decide, well, what row do they start at, what schema do they import, do I recurse the folders, what sort of quote tab, all of the common properties that you might set when you're importing files. And the last one is for every file that I'm importing, I add what we call a data reader, and that's just an individual file. It could have a star in it, so if it's a transaction file, it could be, you know, bob_star.csv, or it could just be a single file, right? And there's various properties that we can change on that to override the default property for the data source. For example, generally my data might start at the second row, but one file might start at the third row or the first row, and so forth. And the last table, package group readers, is for orchestration. I can create an object called a package group that says we'll read all these files for this particular vertical, be that finance, supply chain, and so forth. So we can ignore this bit. This is just clearing down the environment in case I run it away. So emptying all of the tables so it's starting from scratch. So the first thing I'm going to do is insert a configuration, which really all I'm telling it is the name of the sort of data lake. So this is and the fact that there is going to be a managed identity so that the SQL pool can connect to the kind of data lake and authenticate. Okay, so I insert that row. Next, I'm going to insert my data sources. So in this particular one, I've got 3 data sources. I've got some reference data in Excel. I've got some financial transactions in CSV coming from an ERP. And I've got some reference data in CSVs as opposed to Excel. So I'm going to insert those 3. Done. And then the data readers is going to insert the individual objects, right? Now, within this particular metadata framework, we can choose to supply the schema, okay, or we can leave it empty and we can infer the schema. If we're using a tool like sort of Data Factory, it can infer the sort of schema for us if it doesn't know it. Now, obviously, if it's a CSV, it's going to think everything's a varchar, max or whatever. So often we like to tighten their kind of schema to put things as dates and ints and stuff like that. It can make the extract a little bit faster. So I've only defined it on 2 of them. The rest it's going to infer. Okay, so let's run this to add that. And then within the data readers table, I've now got these 7 rows that just define the files that now all I'm really defining is just really the name of the file, because the source tells us where that file is. Now there's some miscellaneous information which is mainly to do with creating the package groups, defining what types of files I'm going to support and stuff like that. So I'm just going to add that miscellaneous metadata. It's more static data that doesn't change from system to system. Right, that's finished now. And now let's actually see that in action, right? So what I can do is if I run this one command, it will generate the T-SQL code to extract a file and bring it into staging, right? But it's intelligent. It will be based on the metadata, okay? Now, I'll run this in Management Studio because Azure Data Studio doesn't do as good a job as rendering carriage returns. So within Management Studio, I can call reader extract and just give it the name of an object. And when I do that, It'll run, it'll take it a little while. And here we can see now it has generated a create table command that's run. It's put the appropriate distribution and kind of table type. Because it's a staging table, it's created it as a heap. If there was any data, it's truncated it, and then it's ran a copy into command, which is generally considered the fastest way of getting data from a data lake into a SQL pool. Okay. Now notice a developer hasn't had to write this code. The stored procedure is generating that code from the metadata. So I go to sort of data readers, I could add another object and it would generate that code for me. So anytime I want to execute it, I just run that command. What it's showing me here is just for debug purposes, so it's not like a black box. As a developer, I can see what that's actually doing now. Okay, so with that, now there's a few other bits and pieces that we call the enterpriseness, or sometimes I call it the fat, right? And that's things with, you know, logging, lineage, and so forth, right? Now that's all stuff that would happen within this procedure. So let's have a look at some of the enterprise features, right? We have an execution log, so every package that runs, that could be an ADF pipeline or an SCS package or a master stored procedure, any of those, they all log to the same table, and we get a log of all the executions, how many source files were read in, if there were any errors, who started it, if it was run from ADF, what was the name of the master package. Obviously, if it's run from a SQL pool, it just says Synapse, and so forth. And then for every file that's extracted, this extract log tells us the name of the object, where it was loaded from, how many rows, what the performance information was, and how many bytes imported, how many bytes per second. It even gives me the request ID, so I can actually query the internal kind of query plan within the SQL pool. So here I can see that it ran a copy into command, and I can actually copy out the exact T-SQL that it ran. I can see the resource group, so it was only running as a small RC, but it was only a DW 200 or 100 anyway, so it's not going to make too much difference. And this lineage key gives me a track to a lineage table that we're discussing now, right? So for every time an extract is done, we stamp a lineage key on it. So say, for example, I look at the data that's imported. I'm just going to query the data that's imported. We see this has got a lineage key of 4, right? So every row is stamped with 4. And then there's another table that will give us that information, right? So I'll just show you that. If I go to my audit table, my extract log will have a lineage key of 4. So as that flows through the sort of data warehouse and all the way up to the star kind of schema, that kind of lineage key is stamped on every row, so we can track back where that data came from. So that's what we call data lineage. And generally, it's very important for data warehouses, especially if you're building stuff that's of a financial nature, because from an audit point of view, you may be asked to sort of justify a value on a report or a query to actually manually trace back where that came from. Now, as well as the kind of custom kind of logging, there is also DMVs available. So there's a list of the DMVs that you can do. And what I've done is I've taken all the interesting ones and aggregated them into a single view that I've called requests. And I wrote 2 stored procedures. I wrote an SP who is active in honor of Adam Mechanic that wrote the excellent SP who is active that runs on the SMP. I've written a very much simpler version that runs on the scale out version, MPPs. And SP who was active says, well, what queries have run, right? So you can use this to see either what is currently running or what was run in the past to look at performance. Now, the SP who was active, that I'm just going to run now, also gives you information on performance plans. So it will tell you how many steps there were, what the time was, what the command was, and then what the most expensive part of the step was. For example, if it was a select statement, you could find that a shuffle or a move is particularly expensive. So this comes very important when we look at tuning kind of later on. Understanding the request and the request steps is 101 of tuning of SQL pools, right? So we get all this information. As well as that, a feature that we always turn on is obviously query store, because with query store, we can turn that on and then we can get the queries out from here. Now, I haven't run any queries, so I'm just enabling sort of query store now, so we'll have to come back to that kind of later on. But after we had run a few queries, we could get an idea of to what the plans were for the queries, if we have any regress plans, average duration, mean duration. So we start to track regression of queries over time or something like that. So query store, very useful features. You don't need to do any special code to include it as part of your framework, right? It's more the custom login that you want to think about. Log in your executions, log in every single row, and optionally is log in the query plan. That's probably going a little bit too far, right? Now let's talk about extensibility as a design principle. As an architect, you make decisions like I'm going to use copy into, right? And a few things will happen. One, the industry will change. So copy into is no longer flavor of the month. Polybase is flavor of the month, or Databricks is kind of flavor of the month, right? So extensibility for me is the ability to either add a new feature to your framework really, really quickly, or to change your mind in how the system is implemented, and for the dynamic code kind of generation to just change. So I'll show you an example of that here, right? So we were using copy into. So if you remember the SQL statement that I ran back here, I ran an extract and it generated a copy into for me, right? But what if I want to use Polybase to either do a logical extract where I point a virtual table and I don't actually physically import in staging, or I want to physically stage, but I want to use Polybase to create a virtual and then just copy from that kind of virtual table, right? Well, what I can do is I can update my metadata here, and we have the ability to plug in these extract kind of methods, right? So I say I now want to call the Polybase, and then I'm going to redo the extract. So what will happen now, we'll just wait a few seconds for this to finish. There we go, that's actually finished now. So what you'll see is instead of generating a copy into the command, it's created an external table, and then it's an insert into that external table from the virtual table. Now, if you use the ADF copy command and you click on Polybase, it does a similar thing, right? You know, obviously we get a little bit more control and we can add features that ADF cannot do. As an example, as we do the select, we stick on a calculated column. Do you see that comma 51 as kind of lineage key? So we can add a calculated column on. That wouldn't be a feature that ADF would support. So for that reason, we actually don't use the copy command to write Polybase. We just write our own Polybase commands, because then we have all of the features that are available, not just the ones that are exposed by ADF. Okay, so that's an example of switching from a copy into to sort of Polybase. Now, what happens if we change our minds? So, say for example, we didn't like the performance, so we switch back to Polybase, and then the product team says, "Oh no, it's faster now." Well, what we can do is we can update our config to say, "Well, let's switch back to use copy," and then we run that, and it's now going to do a copy into. There we go. So it's now just doing a straightforward truncate. Now let's talk about the design principle of robustness, right? So with robustness, we need the automation framework to be able to handle unusual things, right? And as long as it's got the metadata to fix that, to make it so. An example of that is schema change or schema drift. Another example is, you know, do I create a table? Do I not create a table? Is the table empty? Is it not empty, right? So a very, so when people start out, they write what we call very happy path code. Like it only works one way, and if anything changes, it breaks, right? So let's see an example of robustness. So what I'm going to do is I'm going to go to this transactions table, and I'm going to delete it, right? So here's my staging table, staging.transactions, delete, gone. Okay, then I'm going to rerun the command and see what happens, because copy into, if the table doesn't exist, isn't going to work. Take it a few seconds and let's see. Very nice. So now it's recognized that it's got to issue a create table because the table doesn't exist. It's gone to the metadata where it's got a definition of the table, and it's decided to on the correct distribution and table structure. Okay, so that's an example of the design principle of robustness, right? I could as well, I could change it to say, well, I want to run it from ADF kind of rather than in DB, and I want to use a bulk insert. So I just changed the extract kind of method. I could actually do that. Now let's just set it back to use the copy command. That's probably the simplest. And let's quickly move on to orchestration, right? So one of the worst ways of doing orchestration is, say, for example, in ADF, manually joining all the shapes to say, well, I'm going to do this and then that and then that. Because as you change your mind, or you get projects with lots of dependencies, like this particular vertical needs these three, but this vertical needs those two and that one, right? Separating them out becomes hard. So what we do is we create this concept of a package group. So here's a group, finance, and I say, well, for dim finance, here's all of the extract objects that I want to extract. And I've created another package group called transactions, and I create as many of these as I want. And then when I call this stored procedure, it will give me all the metadata that what we call a controller could use to just queue the work and call the work to do the work. And this controller could be an SSS package, an ADF package, or a stored procedure even, right? We don't really care, right? Well, there are differences between those. So here's an example of a stored procedure extract controller. Now, all that's going to happen is when I run this, it's going to decide to do all of the objects that are required for the dimensions for finance and all of the transactions. I could have used the keyword of all as well. So let's run this. Oh, but tell it which synapse to connect to, and it's off. And that's finished now. So you can see it's done a copy into for all of my commands, right? Now, I've done it via a stored procedure, but if you look above here, here's an ADF package that does the exact same thing, right? So it calls a stored procedure to get the queue of work, and then it uses the for each loop to loop over all the objects and call the relevant commands to kind of do the extract. So that's an example of what we call dynamic orchestration, because I can change the sequence of things or what I want to do or what the scope of the work is without having it hard coded into some sort of workflow environment. Okay, let's move on from extracts and onto the more interesting load now. On this section 5 here, this lab 5, metadata load. So we've done the extracts, we have all our data in staging, and it's sort of written all code for us, but we've now got to do the more complex part of transform and then load it into a star schema. Now, before I do anything, I'm just going to run this to just check that we have. So there's this very handy view that someone out there put on the internet, so I can use this to say, give me all the tables in staging and how many rows do they have, right? So great. Got all my dimensions, and I've got a fact table with, now it's not got a lot of rows, you know, it's only AdventureWorks basic without being expanded, about 40,000 rows, right? And then I'm going to create metadata. Now my load controller uses two metadata. EDW tables, which is perhaps badly named because it should really be EDW transforms, describes the transform that is going to be used. And what we typically do is support two types of in-database transforms. Ones that are very basic, right? And I've got a list of about 20 or 30 what we call basic transforms. Casting, typing, business rules, mapping, renaming, dealing with nulls, inferral of data. There's a whole host of transformations that, you know, if you're familiar with Kimball star schema, that have to be done to cleanse your kind of data to make it into a dimensional model, right? If it's just a single step, it just goes in as part of a select statement. So what we do is for every dimension or fact, we create a base view that has all the single step transforms in a single object, right? Now, sometimes you have transforms that are very complex, and we call those multi-step transforms. An example of that could be, well, I've got a source file, I want to load a fact table, but I want to do contra logic where I convert it into deltas based on the information that's in there to get a contra element to negative the stock out and then make it positive. And then I want to also output a log to show the changes to support some sort of, to change it from a snapshot into an incremental type of load. So these are things that would typically need multiple transforms and multiple passes over the data. Now, these multi-step transforms can get very complex. I was just working on a project in the cheese industry. We're calculating the price variation. Took me 3 months to develop the single multi-step kind of transform, and takes about sort of 20 minutes to run, right? So, you know, they can be quite complex. Hopefully, it's just a matter of converting it into the bus matrix and the dimensional model, right? So I'm going to populate these 7. I've got 6 dimensions and 7 facts, and I'm actually just using a view to do the transformations. On a real project, we probably have a couple of stored procedures in there as well, and then I've got package groups that just define, well, when I run this package group, I want these objects to load. When I run this package group, I want to load those objects. Done. Now let's have a look at a very basic transform. The account dimension, which is the chart of accounts, right? So the heart of any financial kind of system is going to be a chart of accounts, right? So what I'm doing is I'm taking the source and converting it into the dimensional model. So now I'm actually creating an artificial parent-child relationship that wasn't here before. So it's a little bit, so the code looks a little bit odd because I'm joining it back to itself in order to create a parent-child, right? But that's just the way AdventureWorks is. I'm doing casting. If it's not found, I'm going to map it to an unknown and a few other bits and pieces, right? Very, very basic transforms. If you were to look at one of our actual projects, the customer and the product dimension could be a few pages of T-SQL, right? But just to show the concept of how you would do that. So when I run that, I've now got a view that gives me the kind of data, but now in the dimensional model format and not in the source, right? Now it's virtualized because it's a view, so I haven't physically moved it, it's just in that view. Now the load part then takes that view and loads it into the star schema by generating the equivalent T-SQL based on the view. If it's a very basic dimension, it could literally be a select into where it's exactly the same, right? But facts obviously get a lot harder because you've got things like surrogation, is it already loaded, and stuff like that. Okay, so let's just see that in action. And I'm going to run this through Management Studio because it renders the output a little bit better, right? USP table load. Now, assuming that I don't have any object, the other thing is we no longer do any physical modeling where we physically create our star schema. The framework will create that table for us if it's missing. So the concept of robustness, as we talked about before, right? So let's just run this and look at the output that it creates. So it's going to generate T-SQL templates to create and or load the dimension. There we go, done. Right, so it's issued a create table, it's put it in a replicated table, it's putting it in a heap. Sometimes we might use a clustered index on a dimension. We wouldn't usually use a column store because the volume of data on most dimensions wouldn't really drive a column store, right? And then it's done an insert into and selected the columns that are to be inserted to, coming from the view to get transformed. It's automatically created a unique index on the business keys. So the business keys in this case is there's a unique business key, so just a single key. Sometimes a dimension could be a multi-key, right? And we've added a row checksum that we use to see if the kind of data has changed, right? Now, if I run this a second time, the table's already there. So the second time, the stored procedure will generate different because it's now got to not create the table, insert it, but only insert the changes, right? So the T-SQL template that it generates now is going to be this. So we see here it's generated an insert into where not exists, okay? So it's only going to insert where it doesn't find, and it's going to update a row, but only where it finds a join on the business key and where the checksum is kind of different. So it's effectively defensive coding, right? Now that's an example of one object. So I can now create and load all of my dimensions just by adding these views and by registering the views within the metadata, so the EDW table. Now let's talk about something a little bit more complex then. Let's go back to here. So we've done a dim account. Oh yeah, login and lineage would then be part of the framework. So as it's extracted, it's going to put a row into a table saying I've done this object, this is when it started, this is any error I had, this is how long it took, and so forth, you know, and it's going to have the lineage to stamp the kind of lineage key on the dimension so we know exactly where that came from, right? So all the stuff that we talked about login and lineage for the extracts, obviously transform and loads need that as well. So we've done the dimensions, and I can now write a load controller for the dimensions to say, well, let's do all of the dimensions at once. So let's just run this just to get all my dimensions loaded, and then we'll move on to the more complex facts. There we go, so that's finished now. It's now created all of my dimensions it's populated them with all the data and stages, it's transformed them all by renaming, casting, unknown values, and all the stuff that you do with Kimball dimensional modeling. Notice that it would have also done them in the correct sequence. So say, for example, organization is snowflaked because it's dependent on currency, right? So a bit of a no-no to create snowflake, but that's what AdventureWorks does. So notice that it does organization last. And it does this by when we register the metadata in EDW tables, we tell it the logical sequence. See this load group here, that tells me the sequence to load them in, so that when it does the orchestration, it can do that in the correct sequence. It also tells us the parallelism. So because these are all in the same load group, I can do all of these transforms at once. They're not dependent on the other. But then this transform's got to be done by itself, and that transform has got to finally be done by itself. So that's how we handle dynamic orchestration and parallelism. Now, that's the full dimension loads. So the last bit, and perhaps one of the more complex things, the facts, right? So the problem with facts is as you load, you've generally got to do the surrogation, right? Because your transform is going to have the business keys on, right? And unless you're using natural business keys, right? So there's a few reasons why you're not going to have natural business keys. If it's a compound key, like it's this plus this plus this, most people in data warehouses would surrogate that with a single key. If your data is versioned, or if you've had to infer things like unknown values that don't have a business key, you're probably going to need a surrogate key, right? So let's assume that some or all of the tables are surrogated. So what we need to do is to left join the view to all of the dimensions to join on the business keys to get the surrogate key back, right? But we don't want the developer writing that code. So what we do is the table load writes that and dynamically executes it for us, right? And we supply it a little bit of help by, as well as EDWs, we have EDW table joins. And this tells us what fact tables are related to what dimension tables. So think of it like a soft coding of the bus matrix. If you know what a bus matrix is, you have all your facts down one and all your dimensions down another, and there's a grid on how they join to each other. So this table helps us understand that. So coming back to the data studio. So what I can do is I can call this table load to dynamically load. Now, if I just naively run it without having put those joins on, I'll get a fact table that has all the business keys on it, right? So it's not going to have that the kind of surrogation. So to surrogate it, I populate the EDW table joins, and then once I've populated, tell it what the joins are, I can run the table load with the name of the fact table. Let's just run that now. There we go, that's finished. It was about 9 seconds, and I've just selected the first top 10 rows to show you we've now got what most people would recognize as a fact table. Keys, surrogate keys, although the date's kind of a smart key, but it's a similar thing. Measures, a little bit of lineage information, such as lineage key. Don't know why with date there, but it was denormalized in the AdventureWorks, so we just left it there. If I look at the T-SQL that was generated, because the table didn't exist, it generated a crate table for us. This time it's put a clustered column store index on it. Still using round kind of robin because the metadata hasn't been told if you want to hash it or something like that, but it's done the surrogation for us. So it's inner joined to all of the dimensions and replaced them with the surrogate keys. The key thing is, a developer hasn't written this kind of T-SQL. You want your framework to generate these kind of templates so that your developers can focus on the business and the data modeling and worry about what we call the piping without having to worry about what we call the piping. Now, because the table's been created, if I run it a second time, it obviously should regenerate that as an insert into with some defensive statement to not load the same data twice, like a where not exists or something like that. Let's run that. Okay, let's run, and we see that this time, oh, sorry, I think I might have told, oh yeah, I issued a drop here, so I'm just going to not issue that drop. Run it a second time without the drop this time. Right, let's run, and now let's look at the T-SQL template that's generated. So now it's generated an insert into, and then it's selected from the query that has all of the surrogation, and it's got a where not exist to make sure the same row is not inserted a second time. Now there's various different templates that we use, such as we might pre-stage and a few other bits and pieces depending on the volume of data. But this is a basic starter template for loading a star schema fact table. Now the very last thing I'm going to look at is orchestration, right? On screen is what you might kind of recognize as what we call manual orchestration. Someone's manually said, do this, and then do this, and then do this. So we don't like manual orchestration because the real world can be more dynamic, and you could have lots of verticals with crossover and stuff like that. So if we look at what we have in these load groups, we can see how the orchestration works here, and it's completely dynamic. So when I run that load controller stored procedure, it does them all in the correct sequence of all the dimensions, and then that dimension last, and then all the facts, right? Now, if I wanted to, I could also run this via ADF, right? I don't have to use a T-SQL load controller. So the last thing I'll show you is that exact same concept, but within an ADF package. So here I have an ADF package which does the exact same thing as the stored procedure load controller, but now it's the controller is running in the cloud in ADF. It's doing the exact same thing. It's reading all of my metadata, got a for each loop and a bit of login and stuff like that, and then for each object or transform, it's going to call the relevant thing, like am I generating a template, am I calling a stored procedure, am I using sort of Databricks or something else, right? It could be any payload really. So I'm just going to run this, and I'm going to do, say, load my entire data warehouse. Now we do the concept of a master controller to do the extract and load, but let's just do the load. So I'm going to trigger now, so I get it multi-threaded, and I'm going to say do everything, and that's now going to run. And once it's running, I'll be able to go to the logging to see that in action. So let's see that in action by going to the logging. Here's my controller run. It's been going 15 seconds. And I can now start to see what it's doing. Let's just refresh this. Execution starts, so it's probably enumerating the objects now. And then the for each loop is going to be firing. So let's just leave this running a while. Okay, so running, it's now hit the for each loop, and the workers are going to start to do the loading multi-threaded. That's now finished, so my transform and load part of my data warehouse is finished. I can switch to the Gantt chart view, it's probably easier to view. I can see that the for each loop did 3 loops, so this would be the first group of packages here and the next group here. If I drill down on that, I can then go into the individual objects that were loaded. So here I can see in the first load group kind of 0, I had 1, 2, 3, 4, 5 tables that were loaded, and I can see all of the properties that ADF exposed, like how long they took, how many rows, and so forth. So that's just an example of an ADF load controller. I can choose to have a load controller running in DB or outside of DB in the cloud if I want to. Okay, so we've pretty much run out of time, but I've shown the basics of automating the setup of Synapse and the various pieces around there, like kind of SQL pulls, automating an extract controller using metadata so that you're not writing any code to do extract anymore, and the more complex business of automating transforms and loads to create these like libraries of like views or procs or whatever you're using to do your kind of transforms, and then have some framework that does the orchestration around that. I'll be available for sort of Q&A, so if you want to have a chat or ask any questions, please do. Thank you very much.